This exercise is 2 in 1. In each case, we have to evaluate the integral of a vector function, a 3D vector in each case, one of them with the ijk notation and one in the angular bracket notation. And also, one's an indefinite integral and one's a definite integral. Let's get started with the first. Okay, I copied our function, and now the integral of that function, what we do is we just take the integral of each component separately, put the integral here, here, and here, and this is what we get. And now it's just a practice in integration. So what we get, the integral of 3t squared is an immediate one. It's t cubed, but we still have the I. And for the second integral, I want to remind you in general what's the integral of tangent x dx, or let's say tangent t dt. This is equal to minus the natural log of cosine t. Actually, this should be an absolute value. And that's because tangent is sine over cosine, and it's the derivative of the denominator in the numerator minus. Anyway, this is a basic one. So for here, because of the 2t, we're going to have to divide by 2. So we get plus a half from the 2. The minus gets swallowed up with this minus. Natural log of cosine 2t in absolute value. And the last one, I guess we also should add that the denominator shouldn't be 0. T cubed can't be 1, which means that this is defined for t not equal to 1. That's okay, that's technical. Now, here, notice that the derivative of the denominator is the numerator. And whenever I have the integral of something prime over something, d whatever variable it is, this is just the natural log of that something. Because if you differentiate this, you get 1 over this times this derivative. Actually, this should be an absolute value. So here we have the natural log. I forgot the j here, sorry. Yeah, natural log of absolute value of t cubed minus 1, and I mustn't forget the k. But that's not all.